Okay, start recording. Okay. I think I have everything. All right.
What are isotopes? Isotope is a word that gets thrown around in chemistry a lot. So, what are they? Really
Really
quickly,
quickly,
isotopes
isotopes
are
are
different
different
versions
versions
of
of
an
an
element,
element
or
or
different
different
versions
versions
of a
of a
certain
certain
kind
kind
of
of
element.
element.
This
This
can
can
be
be
a
a
tricky
tricky
concept.
concept.
Okay, so that is our first blank. Isotopes are different versions of an element. So that first blank is versions. That's okay. So we think that all atoms maybe of carbon are all identical. That's not the case. Some of them are a little bit different than others.
Different versions of a certain kind of element. This
This
can
can
be a
be a
tricky
tricky
concept,
concept,
though,
though,
and
and
a
a
lot
lot
of
of
people
people
get
get
confused
confused
by
by
isotopes.
isotopes.
So,
So
I
I
want to
want to
describe
describe
them
them
by
by
starting
starting
out
out
with
with
an
an
analogy
analogy
to
to
cars.
cars.
Okay?
Okay?
I
I
want
want
to
to
talk
talk
to
to
you
you
about
about
the
the
made-up
made-up
car
car
called
called
the
the
Lamona,
Lamona,
the
the
epitome
epitome
of
of
luxury,
luxury,
and
and
it's
it's
known
known
for
for
its
its
very
very
distinctive
distinctive
styling,
styling,
as
as
you'll
you'll
see
see
the
the
Lamona.
Lamona.
If you're wondering why he's chosen Lamona, a car that has like lots of problems all the time, it's always breaking down, is called a lemon. Okay? So that's I think why he's chosen the Lamona, because it's kind of a reference to a car that breaks down all the time.
Looks like a lemon. Now,
Now,
the
the
Lamona
Lamona
comes
comes
in
in
three
three
different
different
models.
models.
There's the
There's the
Lamona
Lamona
G,
G,
the
the
Lamona
Lamona
GX,
GX,
and the
and the
Lamona
Lamona
GXL.
GXL.
They're
They're
all
all
different
different
colors,
colors,
as
as
you
you
can
can
see,
see,
but
but
each
each
of
of
these
these
models
models
also
also
has
has
unique
unique
features.
features.
One
One
has a
has a
radial
radial
and
and
leather
leather
seats.
seats.
The
The
GX
GX
here
here
has
has
chrome
chrome
wheels
wheels
and a
and a
CD
CD
player,
player,
it's
it's
blue.
blue.
The
The
red
red
GXL
GXL
has
has
massaging
massaging
seats,
seats,
platinum
platinum
spinner
spinner
wheels,
wheels,
and
and
everything.
everything.
But
But
here's
here's
the
the
point.
point.
They
They
are
are
all
all
Lamonas.
Lamonas.
They're
They're
all
all
Lamonas
Lamonas
because
because
they
they
all
all
have
have
this
this
distinctive
distinctive
style.
style.
They
They
look
look
like a
like a
lemon,
lemon,
and
and
that's
that's
what
what
makes a
makes a
car
car
a
a
Lamona.
Lamona.
Okay?
Okay?
So
So
it
it
doesn't
doesn't
matter
matter
what
what
color
color
it
it
is,
is,
and it
and it
doesn't
doesn't
matter
matter
the
the
various
various
options
options
that
that
you
you
get
get
in
in
these
these
models,
models,
the
the,
G,
G,
the
the
GX
GX
or
or
the
the
GXL.
GXL.
What
What
matters
matters
is
is
that
that
they
they
all
all
have
have
this
this
particular
particular
shape.
shape.
That's
That's
what
what
makes
makes
a
a
Lamona
Lamona
a
a
Lamona.
Lamona.
So
So
we
we
have
have
these
these
three
three
different
different
models.
models.
I
I
want to
want to
use
use
this
this
analogy
analogy
now
now
to
to
talk
talk
about the
about the
same
same
thing
thing
but
but
with
with
atoms.
atoms.
I
I
want to
want to
now
now
introduce
introduce
you
you
to
to
three
three
models
models
of
of
carbon,
carbon,
just the
just the
way
way
there
there
are
are
three
three
models
models
of
of
the
the
Lamona.
Lamona.
Okay?
Okay?
Here
Here
are
are
the
the
drawings
drawings
of
of
each
each
one
one
of
of
them,
them,
and
and
what
what
we're
we're
particularly
particularly
concerned
concerned
about
about
is
is
the
the
nucleus.
nucleus.
I'm
I'm
using
using
these
these
red
red
dots
dots
to
to
symbolize
symbolize
protons,
protons,
and
and
I'm
I'm
using
using
the
the
blue
blue
dots
dots
to
to
symbolize
symbolize
neutrons.
neutrons.
The
The
swirly
swirly
circles
circles
are
are
supposed to
supposed to
represent
represent
electrons
electrons
that
that
are
are
buzzing
buzzing
around the
around the
nucleus,
nucleus,
but
but
we
we
don't
don't
really
really
want
want
to
to
worry
worry
about
about
that
that
too
too
much
much
right
right
now.
now. Anyway,
these
these
three
three
models
models
of
of
carbon
carbon
are
are
carbon
carbon
12,
12,
carbon
carbon
13,
13,
and
and
carbon
carbon
14.
14.
So we're just going to pause so you can fill in carbon 12, carbon 13, and carbon 14. You write the name, then you write a dash, and then you write the number. So carbon dash 12, carbon dash 13, carbon dash 14. Make sure you've written that down. Carbon dash 12 in that first blank. It's already written for you. Carbon dash 13 for the second atom. Carbon dash 14 for the third atom. So these are all different versions of carbon. What do we call it when we have different versions? We say they are different what? Starts with the letter I. Isotopes. We have three different isotopes of carbon. Carbon 12, carbon 13, carbon 14.
Let's look at the options. And
Like we did with the Lamona, let's look at how each one of these different types of carbon differs. Okay?
So
So
if
if
we
we
count
count
the
the
number
number
of
of
protons
protons
in
in
carbon
carbon
12,
12,
we'll
we'll
say
say
it
it
has
has
6
6
protons.
protons.
And
And
if
if
I
I
count
count
all
all
the
the
blue
blue
spots
spots
here,
here,
I
I
have
have
6
6
neutrons.
neutrons.
Okay?
Okay?
so you can fill in the box where it says protons 6, neutrons 6. How do you think that 6 and that 6 relate to the number 12? They add together to make the number 12. Yes, they do.
Carbon 13, 1, 2, 3, 4, 5, 6. Red spots, 6 protons.
In this one, I have 7 neutrons, and in carbon 14.
Okay, so you're going to fill in protons 6, neutrons 7 for carbon 13. P6, N7.
Down here, I have 6 protons, and I have 8 neutrons. So what do we have in common?
So let's just move that for a moment so you can see it. Protons for carbon 14 is 6 and neutrons is 8. What do you get if you add 6 and 8? 14. Oh my goodness. What do you get if you add 6 and 7? 13. But what's the same about all the different carbons? They all start with 6. What do they have 6 of? Protons. They all have 6 protons. What is different about them? The number of neutrons, which, if you recall, protons have a mass of 1 AMU. Okay, so protons mass is equal to 1 AMU. Hopefully you remember that from the other video I had you watch. If you don't remember it, I'm writing it down for you now. Do you remember what AMU stands for? Atomic mass units. Neutrons. Yeah. The mass is equal to 1 atomic mass unit. So those are our protons and our neutrons. What do you remember about the, if you could take a photo or write it down, either way is okay. Yeah? There is a value for this. You are not required to know the actual value. What you need to know is that the mass is very small. Way smaller than the mass of a proton or a neutron. So it's like if you have an elephant on a scale and a fly lands on the elephant, the fly being the electron, does the fly make any difference to the mass of the elephant on the scale? Probably not enough that we could actually see any difference. So these are very small, so it does not count towards the mass of the atom. Yeah, it's like 0.000549, which is about 1/1800th. Okay? But you don't need to know that number, you just need to know it is very small. Okay? I'll leave this up here, so if you want to copy it down later, or if you want to take a picture, you can do that. Okay? For now, we're going to go back to our isotopes.
8 neutrons. So
So what do we have in common here? All the different models of the lamona, even though there are things that they differed about, all have the same distinctive lemon-like shape. So for carbon, what they all have in common is they have 6 protons. 6 protons in the nucleus. And that's what makes a carbon atom a carbon atom. Okay? So it turns out that it doesn't matter how many neutrons it has. 6 neutrons, 7 neutrons, 8 neutrons, no big deal. It's just like painting the lamona different colors or adding a radio or a CD player. The neutrons, it doesn't matter. It doesn't change the fact that each one of these are a carbon. That's because carbon is defined by the fact that it has 6 protons in its nucleus. If you look it up on the periodic table, you'll see something that looks like this, and the number up here is the atomic number, 6, which means that if an atom has 6 protons, it's carbon. Okay? So that's what these all are. They are all isotopes of carbon. They're different versions of carbon or different models of carbon of the same.
Now, just before we go on, when you have your periodic table, and we have carbon, and up at the top there's a number 12. What do we call that number up at the top of the periodic table? Mackenzie? That is our atomic number. And literally its job is to tell you the number of protons. So if I say the atomic number is 17, how many protons are in that element? 17. If I say the proton number is 84, what is the atomic number? 84. Okay, so they are identical to one another. Okay. Okay. I'm just waiting because there's a couple people writing stuff, so I'm just going to give them a moment. Yeah. And if I'm standing in anyone's way, just tell me to duck down. I can do that. Okay.
Same number of protons and different number of neutrons.
So look at how I wrote this. I've got carbon 12, carbon 13, carbon 14 up here. I want to take a minute and talk about the numbers. So the number of protons in the nucleus, we call that the atomic number. You may already know. And then
Okay, so you can fill that in that box beside protons. It says atomic number, which is hard to read because his hand is over top of it. Let me see if I can get a better picture. There we go. Nope. Let's see. Atomic number. It says that. There you go. If you can't read it, okay. And that just goes in the box beside protons. Okay.
This 12 that I've written here refers to a different number, and we call that the mass number.
Okay, so we have the atomic number and we have the mass number. And tomorrow we're going to look at the atomic mass, which is on your periodic table. The atomic mass is not the mass number. You guys know that that little number symbol means number, right? It doesn't just mean hashtag. Okay, good. Well, it's really funny because, apparently somebody, like a little grade 8, did not know. They're like, someone wrote do question number 5, right? And they were like, why does it say hashtag 5? Anyway, I thought that was funny.
The mass number, as you'll see, is the number of protons plus the number of neutrons.
So this is carbon 12. 6 plus 7 protons and neutrons is 13 here. 6 plus 8 is carbon 14. So that's how we distinguish between these different isotopes.
So every isotope has a different mass number. Yes, every different isotope has a different mass number because every isotope has a different number of neutrons. Yeah.
Different types of carbon.
There's another way that we sometimes indicate these different isotopes of an atom instead of doing 12 and 13 and 14, and that's by using something called isotope notation. Let me show you how we do that. The way we write carbon 12 or 13 or 14 isotope notation is we start out with the chemical symbols. If you don't already know that, you can find it on the periodic table. So here it is. It's a big uppercase C. So I start with my C for carbon. And then on the lower corner here, I write the atomic number. So that's going to be 6. And then up top, I write the mass number, which is 12. So this is carbon 12 written in isotope notation.
Okay, so you are going to write down 12 in the little box that's up here and 6 in the little box that's down there. Or I don't know if there's a box. Yes, there is a box. Okay. Where does the mass number go when you write out the whole name? When you write the whole name, carbon, C-A-R-B-O-N, where does the mass number go? It goes after, and what do you have to put in between the name of the element and the mass number? You have to put a dash. So there's the name and then dash and then the mass number. When you write the symbol, the letter C, where does the mass number go? It goes at the top on which side? It goes at the top on the left. It doesn't go up here. We're going to put something else up there. Okay, there's actually things that can go here and here and here and here. The mass number is the one that goes at the top left. What goes at the bottom on the left? That's the protons. So we have protons, and then we have protons plus neutrons equals the mass number. So protons plus neutrons, protons plus neutrons, protons plus neutrons, protons plus neutrons, protons plus neutrons. Okay.
Carbon 13 is going to be 6 again, because all carbon has 6 protons in its nucleus. Then the 13 up here. And finally, carbon 14,
written in isotope notation, C614.
Okay, so you can fill that in. Oh, look, what do we have here? We have protons plus neutrons, protons plus neutrons. And if we write the whole name, carbon, we have to write a dash, and then we write protons plus neutrons. Sorry? Oh, yeah, you write the carbon, and then you write the 14 and the 6. Sorry, so in the third one, you're writing this entire thing so that you get a chance to write both the symbol, the 14, and the 6. Good question.
So that's how we can write all these isotopes of carbon isotope notation. Then, of course, you can also write it as just element name with a dash and then a number. So
carbon isn't the only type of element that has multiple isotopes. In fact, just like cars, almost every form of element comes in multiple isotopes. Here are the calcium isotopes, for example.
Oh, come back here. Oh, I just want him to not have his paper over the top. Oh, there we go. Okay, so let's look at all of our calcium isotopes, and you can write down some of the stuff. We start with calcium 40. It has 20 protons. Then we have calcium 42, which has, guess how many protons? 20. And then, this is the one you can fill in, calcium 43. How many protons? 20 again. And then in this case, if you didn't know the number of neutrons, you could say 43 minus 20 gives you 23. Now up here, even if you weren't given this information, even if all you had was what was written on the page, you know that the protons are 20, which means that this element is calcium. Yes? You know it's calcium. What is the mass of calcium if we have 20 protons and 24 neutrons? 44. Right? So even if that wasn't written there for you, you would be able to figure it out. There's a little box here. See if you can fill in that little box with the symbol and the mass number before I put it up on the screen, okay? So like over on the side on your paper, you can see there's the isotope notation with Ca, and it has the mass number and the atomic number. See if you can fill that one in for this one before it comes up on the screen. Give it a try anyway. Are we ready to carry on yet? Oh yeah. We can take our time. There's no rush. We are writing down, there's a box here, and we're going to write down what goes in that box. But it's okay if we don't get it, because it will come up on the screen in a minute. Okay.
If you
If you
look
look
up
up
on
on
the
the
periodic
periodic
table,
table, you'll see that calcium has an atomic number of 20, which means that any atom that has 20 protons in its nucleus is calcium. But just like with carbon, you can vary the number of neutrons that are in the nucleus, you get all these different isotopes, but you still have calcium. Calcium, we got 40, 42, 43, 44, 46, 48, all of them have 20
So many
protons in the nucleus,
isotopes.
but they have varying numbers of neutrons. Just like we did with carbon, we can write all of these calcium isotopes in isotope notation, where we have the mass number here up at the top and the atomic number down at the bottom. You see they all have the same atomic number of 20, but different mass numbers, the sum of protons and neutrons.
Okay, so if you missed anything there, you have a chance now to fill that in. Okay. Grab a pencil. And then at the bottom right of that box, you have the calcium, the mass number. Carbon. And then we have these numbers, so yeah. And the mass number is at the Okay.
The same is true for iron, just to give you another example.
Iron has 26 protons in its nucleus, an atomic number of 26. And there are 4 known isotopes of iron, all of which have 26 protons in the nucleus, but they all have varying numbers of neutrons. You add these together to get the mass number, and then you can write it in isotope notation with the mass number up here and the atomic number down here.
Okay, so you can see for all of those, they're all iron. And if you write in the number of protons is 26. Protons is 26. Protons is 26. Protons is 26. What number goes at the top? Mass number. What number goes at the bottom? Atomic number. Mass number. Atomic number. I'll let you finish writing and then I'll repeat things a lot of times. Okay, so up at the top on the symbol, mass number, atomic number, mass number, atomic number, mass number, atomic number. What goes up here? What goes down here? What goes up here? What goes down here? Zenny's gonna know it. I don't know about the rest of you. Now, up at the top, protons plus neutrons, protons, protons plus neutrons, protons. Say it with me, honest to God, and do this too, because I will tell you when you activate protons plus neutrons, if you've got your voice high and your hands high, you've got all the different neurons. You've got the sound neurons, you've got the physical neurons, you've got the sight Neurons, right? You've got them up there. Protons plus neutrons, protons, protons plus neutrons, protons. Everyone, hands up in the air. Protons plus neutrons, protons, protons plus neutrons, protons, protons plus neutrons, protons. Okay, and if nothing else, at least we got a little exercise, right? So, all right, and that is it for that. Today we are going to be working on your activity. We will be doing the part where today in groups of, let's try 3 or 4, just because we only have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 kids. We should be all right. Groups of 2, 3, or 4. Groups of 2, 3, or 4. And in your kit, you will find a whole bunch of different elements. You may notice that some of them, not finding them, oh my gosh, what's wrong with me? Maybe they're at the back. Oh look, here's hydrogen. Oh, there's nothing in there. Or at least it doesn't look like there's anything in there. That's because what do you know about the state of hydrogen? It's a gas, and it is a colorless gas. Okay, so really, the only two things you can say about hydrogen at this point is that it is a gas and it is a colorless gas. Okay? Yeah, you can't really smell them. Now, the other thing is, around the room, you might look around and say, oh, look, there's lots of microscopes. Okay? So if you look up into this microscope, in this one, we have, there's a little orange tag and it says ZN. Can you guess which element this is? This is zinc. And I have set up the microscope so you should be able to look through and see the zinc. Okay? But the next one over here, this one isn't zinc, this one says PB. Does anyone know what PB is? Lead. So you will find microscopes over there, here, here, all the way around the side and back of the room. Take an opportunity whenever you have an opportunity that one is open, go and look with your group. If they are all busy, then just wait until it becomes free and use your regular samples in the meantime. Yes. Okay, go sit down. I'm going to finish the instructions. There is a part 3, which is where you're doing chemical reactions. We won't be doing that today. We will be doing that tomorrow. Okay? Yeah, that's a really good question, and I'm glad you brought that up. So part 1, you're looking just with your naked eye. Don't worry about whether it is magnetic. We have some magnets, but they're not really strong enough. Okay, if you want to try some of yours with a magnet, where did I put the nice magnet? Oh, I had it yesterday. Oh, phooey. I don't know. We'll worry about magnets. Oh, here. I have one really good magnet. Okay, so you can try this one really good magnet. Okay, but I will bring more magnets tomorrow. Okay, from my house. I'll just bring them from home because the ones here, I tried them. They don't really show you much of anything. Okay, but if you want to try it today, there's one. It's right there. You can help yourself. Okay? Yes? No? Okay. Since you are not doing anything with your eyes, like that could be dangerous, we have no liquids, you do not need to wear safety goggles. If you are uncomfortable having your eyes touching something that might have touched other people's eyes, you can feel free to use safety goggles if you want to, though. Okay? Questions? All right, I need to give you back your sheets, which I just put somewhere cleverly. Okay, just give me 1 minute. I've put them down. Just had them a minute ago. Not there. Not there. Not there. Not there. No, I put them down somewhere clever. No, I put them down somewhere clever, which means that now I need to wander around the classroom and find them. Oh, bless you. You are awesome. Thank you. This is why we have many eyes in the classroom. I'm like, I don't know where I put them. And they're like right here. Okay. So anyway, Matthew, you got yours. Alyssa. Yeah. Get yourself a set of elements, or you can start by looking through the microscope. It doesn't matter. Wine, everybody. Oh yeah, for sure. If your microscope is not in focus and you need some help, call me over. No, you're gonna take an entire kit. Take an entire kit. You'll do all of them in the kit. Yeah, so you don't just take one element this time. You just take one last time because we had no time. Take an entire kit. That's okay, I have that. I'll do it right now. No worries, that's why I made that first, because you know, when I'm things from one day to the next. You see, I put it on the table and now it's gone. I don't know. Hi.
So we found the element.
Mm-hmm.
Found it on the periodic table.
Yep.
And then
And then on here, we're going to fill in the name, symbol, the atomic number, the atomic mass. We'll decide if it's a metal, non-metal, or metal-like. And then
put down all of the information for all the
yes, exactly. And if you have questions, just let me know. Yeah, perfect. Do you not have yours from yesterday?
What do you mean? Oh, that one.
Because the vial is made of plastic. Sulfur smells funny. Yeah. Well, oxygen are like too. But the air is actually. Oh. Oh no. What was happening? Wrecked myself. Hello. If you want to open the vial, take a little clearer look at it, you can, but don't touch the element because you never know which ones are safe to touch. Okay? So for example, lead can cause lead poisoning. So definitely don't touch the lead. But you can open and look. Don't open it. No, yeah, you never know what's happening. Exactly. I opened the one what you actually yeah. Yeah, why? No. We used to have some aberration in that one in order to like that kind of dangerous. Yeah. You don't like anything with your death. And don't be shy about going and looking at the elements under the microscope and breaking
isotopes in there as well. We all smell like crayons because that's what plastic smells like. I don't know. It's been around for a long time. Just skip we'll look at magnetic tomorrow together. Skip smells, skip magnetic, yeah. I should really just get rid of
So just to review what we
Oh, sorry, no.